Hello friends. Here is a question that trips up a lot of beginners. Imagine you ask a program to print the numbers 1 through 5. The program does it, but how did it know to stop at 5 and not go on forever? A computer does not just sense when enough is enough. Something inside the loop has to keep score, check a condition, and eventually say we are done. That something is a loop variable. Without it, your loop has no memory, no direction, and no exit. In this video, we are going to pull that mechanism apart, see exactly how it works, and learn the mistakes that break it. Let's start with what a loop variable actually is. A loop variable is simply a named storage location, a variable that the loop uses to track its own state as it runs. Think of it like a lap counter at a race. You set it to a starting value before the race begins, you update it after each lap, and you check it to decide whether to keep going or stop. In most loops, you will see this variable called I, but the name is just a convention. What matters is the 3 jobs it does. It gets initialized to a known starting point. It gets updated on every cycle. And it gets tested in a condition that controls whether the loop continues. Those 3 roles, initialize, update, condition, are the whole story. Next, let us watch all 3 happen live inside a real loop. Alright, let us trace this loop together. We write for, followed by 3 parts in parentheses. First, int I equals 0, that initializes I to 0. Second, I is less than 5. That is the condition checked before every cycle. Third, I increment. That updates I by 1 after every cycle. Now watch the table on the right. Cycle 1. I is 0. The condition is true, so we print 0, and then I increments to 1. Cycle 2. I is 1. Condition still true. We print 1. I becomes 2. This continues until cycle 5, where I is 4. Condition true. We print 4, and I increments to 5. Now the condition checks 5 is less than 5. That is false, and the loop exits. The loop printed 0 through 4, which is 5 values total. Next, let us look at what goes wrong when you get those 3 parts slightly wrong. Now look at this. 2 mistakes that show up constantly in real code. The first is the off by 1 error. Suppose you have an array of 5 elements at indexes 0 through 4, and you write the condition as I is less than or equal to 5 instead of I is less than 5. On the final cycle, I equals 5, your loop tries to read index 5, which does not exist, and your program either crashes or reads garbage memory. The fix is simple. Use strictly less than the length, not less than or equal. The second mistake is the infinite loop. This happens when the update step is missing or broken. I never changes, the condition stays true forever, and your program freezes. Every loop variable must have a clear, reliable update. Get the initialization, the condition boundary, and the update all consistent with each other, and most loop bugs vanish. Here is how to lock all 3 in. Alright, let us bring it all together. A loop variable does exactly 3 things. It gets initialized to a starting value, it gets tested in a condition before each cycle, and it gets updated at the end of each cycle. Get all 3 right, and your loop runs precisely as intended. Get any one of them wrong, and you end up with either an off by 1 error or an infinite loop, as we just saw. The key takeaway is this. A loop variable is not just a counter. It is the mechanism that gives your loop memory, direction, and an exit. The best way to make this stick is to write a short loop yourself, trace it on paper cycle by cycle, and then deliberately break it so you can see what goes wrong. Thanks for watching, and happy coding.